In this tutorial, we're diving into creating custom procedural grid line textures with Blender shader nodes. With this node setup, you'll be able to scale the texture as you see fit, as well as control the size of the lines and intersection markings. You'll have access to this full grid output, as well as maps that only contain just the grid lines or just the markings. As with all my tutorials, my goal is to not only show you what to do, but explain why I'm doing it so you can learn how to think about creating procedural materials and textures on your own. With that out of the way, we'll start by adding a plane, creating a new material, and adding a texture coordinate node to it. For this tutorial, we'll be using UV coordinates to create the grid lines. I tried making this work using generated or object coordinates to avoid the need to UV unwrap, but trying to create this in 3D space gets surprisingly difficult. If I manage to figure out how to overcome those problems I'm running into, I'll release a follow-up tutorial. If you're not familiar with how UV coordinates work, the short version of it is that it's a two-dimensional coordinate system that we use for texture mapping that functions exactly like a graph with an x and y axis. By default, the origin of the UV coordinates are in the lower left-hand corner, meaning that we're only seeing the positive values of the UV space and they range from 0 to 1 on both axes. If we want to extend this range, we can add a vector math node and set it to scale. This will give us a single control to universally scale our grid lines. I'll increase it slightly so we can see any repeating patterns that develop. To create the grid, I'll need a way to draw horizontal and vertical lines. Luckily for us, we can access the underlying texture coordinates by using a separate XYZ node. If I take a look at the X values, we can see this black and white gradient. In Blender, numbers can be represented as colors, with black being 0 and below, white being 1 and above, and gray being everything in between. So what we're currently looking at are all the X values on this plane from 0 to whatever value you've scaled up to. Now, if I add a math node and take a look at the functions, there's one named ping pong, which we can use to draw our lines. If you haven't used ping pong before, what it does is return a value that oscillates between 0 and 1 based on whatever interval you give it. So as an example, with the default settings of 0.5, ping pong returns 0 at the origin. As we move to the right 0.5, we can see that the value it returns gradually goes up to 1. If we go to the right another 0.5, the return value drops back down to 0 and the pattern repeats. I'll leave this set at 0.5, since it'll give us the same number of lines as what we set our scale to, which makes the scale input more intuitive to use. With that, we now have the basis for our grid lines. We can use something like a less than node to turn the gradients into discrete lines, and since the underlying values are a gradient, we can adjust the threshold to control the thickness of the lines. I'll duplicate this setup for the Y values to get our horizontal lines. Now let's think about combining them. The less than node can only return two possible values, 0 or black wherever the threshold condition is false, and 1 or white wherever this condition is true. So I have two maps that only contain zeros and ones, and I want to overlay them on top of each other in a way that keeps all of the ones since those represent my lines. To do that, I can use a maximum node, which will compare the values at every point of the two maps against each other and return the bigger number. This will give me the union of the two sets of lines. Now that we have the grid, let's make the texture more interesting by adding cross marks at the intersections. So the first thing I'm thinking about is if there's a way to easily identify where the intersections are with our current setup. Well, if we look back to the logic we just used to combine the lines, the intersections are represented numerically where both maps contain the value 1. So instead of using the maximum to compare the maps and return the larger of the two numbers, I can use the minimum instead to return the smaller of the two. That'll give us only the areas where the lines overlap. In other words, we're taking the intersection of the intersections. Just like before, we can use the threshold to adjust the size of these marks. To turn these squares into crosses, I'll once again duplicate our grid line setup and increase the line thickness a little bit. So this map contains the cross shape we're looking for, we just don't want the lines to run the entire length of the surface. I want to isolate them where the intersections are, which the last map we just made identifies. To cut out the cross shape within the squares, I can use the same logic to take the intersection of the two maps by using another minimum node. So we now have 4 controls that we can use to change the appearance of the markings. These two up here control how long the marks are. And these two down here control the thickness of the marks. Something you should note is that in order for this to look like a cross, the outer thresholds need to be bigger than the inner thresholds. Otherwise, you'll just end up with squares or rectangles. Anyway, to assemble the full grid, we can take the union of these two maps with a maximum node. And with that, we now have a procedural grid texture in Blender that allows us to output this full grid, just the grid lines, or just the intersection markings with full control over how each element looks. This can be used as a base to create other interesting procedural materials and textures, limited only by your imagination. If you do use this to make something cool, feel free to tag me in it, as I would love to see it. My socials are in the description.